Hey YouTube, it's Dimitri, and how many types of quants are there really? So I feel like I lied, but not really. So let's dive into this real quick. Back in 2017, let's look at this video here, August 13th, 2017. I have a very popular video with over 40,000 views right now, and it's on the 6 types of quants in the industry. Like, there are 6 types of quants. Now, back in 2017, I made this video content off of an article, so kind of taking what Mark Joshi had, and I'll put this on the screen here as well. On Becoming a Quant by Mark Joshi. He's no longer with us, unfortunately, but somewhat of a legendary quant in the quant space. He gives a lot of advice and tips here, so I'll link the video as well. If you go to that video, that other video, you can listen to me talk about the 6 types of quants. You can click on the link below. I believe I'm one of the only people left sharing this document. Oddly enough, I originally downloaded it, and then I made the video, and then it disappeared off the internet, and I had to search for it for some time. Somebody ended up having it, sending it to me, and I've saved it here for you guys. But Mark Joshi, I believe in his document, has 4 types of quants. I add 2 more quants, I believe, somewhat based on this format, this documentation, somewhat based on other research back in 2017. And you can see here there are 4 quants listed on his. There's front office desk quant, model validation quant, research quant, quant developer, and I ended up adding statistical arbitrage quant and capital quant. These were kind of these 6 groupings that I had seen and talked about, and I was talking to a lot of industry practitioners back in 2017, and the reality is there's only one type of quant. Now we can differentiate them a little bit here. So let's differentiate the different jobs, responsibilities real quick. I'm going to argue that quant finance, or more specifically, right, that people know this as quantitative finance, this is no longer a job. So quantitative finance as a job is dead. Why? We've rephrased things. The industry's gotten smarter historically, but realistically, I think quant gets thrown in as a job. It is a slang term. That was how it was originally used. People have historically kind of grasped to it. Even today, it has a negative connotation, even though a lot of people now associate it with a high-paying job. So let's say modern times equate quant just meaning like high pay. And they wave their hands and they say, oh, if you do addition, subtraction, multiplication, or division, you are now a quant. So all this is kind of losing meaning as of historically, right? So historically, we had quants, financial engineers. That's the technical proper term for this. They were those engineering financial products. They were only on the sell side. Only those that worked at banks engineering financial products were quants originally. Now, it's kind of morphed over time, and the skill set, people started to realize you needed math, stats, and computer science, and you could apply this into finance. And so anybody that kind of did that now has been called a quant. Over the years, we have specialized, we have polished the industry, we have gotten very specific on jobs and job titles now. And I think Mark Joshi's really hitting at this in, I don't know when his original article came out, I think it was like early 2000s. He's starting to hint at the fact that like we used to have this fuzzy area of quants, and now he's kind of breaking this down into the jobs within the quantitative finance industry. So trying to differentiate here. A lot of people work in the industry, but not everyone does the same thing. And so the skills are different. And so the 6 types of quants, his original article and my video, are going to get into kind of the process of what quantitative finance does, like how firms make money. I've mentioned this before. I think this is quite odd, but data engineering, I'm going to say it again. These are the unsung heroes. We kind of just exclude them from the quant process. And we often do that because a lot of data historically, many firms are just purchasing data. It just comes packaged, cleaned, and everything. Now, in modern times, that's not the case. We have got many data sources. We're pulling in data from all these different, vendors, whether it's like bureaus like TransUnion or Equifax or LexisNexis, or you're starting to look at traditional vendors like Bloomberg and FactSet and Data Bento and Quant Connect. They're starting to aggregate now all these data sources for you, these companies, and put it all together. So data engineering is something that's critical to the industry. When you're at a smaller firm, you have to do this. You have data engineers. You should have data engineers, data governance, data quality. These sorts of things need to go into the data side of that. But we typically, I'm going to put a little line here, we typically pretend they don't exist, but you need them. They're required. And then next up on this list is going to be quants, which is this is typically what I call a quant, but let's not get into that real quick. These are going to be people that are going to be doing model development, or more specifically, some sort of quantitative research. And I'll link a video above or below as well on that. I had a video recently talking about model development versus quantitative research and how the two are short-term and long-term and how you need both of them to run a firm. But these are going to build the models, the strategy. They're going to put it together here. And then this needs to go and needs to get implemented. And to get implemented, you need what we call quant devs. And then after it gets implemented into a tool, you're going to have the business here. And this is going to be your traders. This is going to be your analytics. So after let's go through this process. You build a model that does something. An implementation team implements that model using probably like C#, C++, maybe Python these days. And you put it into some sort of tool, and then the business uses the model. They're running the model and they're making decisions, but they have to analyze the results. You don't just blindly use a model. And there's other things like ongoing performance monitoring that the developers need to do as the model's running. But the front end of this is going to be the analysts, the traders, the businesses, the bankers, the loans, the sales staff, the people that are using these sorts of tools. And they're going to be tracking the performance of this, right? Your model said, if I did this, I would get this result. And so you're going to have tracking here. Now, this is what we would call front office, okay? So typically people say, oh, I want to end up on the front office because historically they made the most money. They were the closest to the problems. They were using the models. They were doing the trading. In the banking side, right, they are strategically using the models and saying, we want to set thresholds and cuts, and only these products are going to use this sort of model, and then it's going to be adjusted over here, and then now the model's failing, so now we're going to readjust. And they are viewed from the business staff, the CEOs, the COOs, the CFO, like the executive staff, the portfolio managers are going to be in this front office role. Everyone views them as making the money historically. Now, as quant finance has gotten very competitive, as computers have been on the rise, they've started to realize that those building the models are absolutely critical, so we need to pay them more. And then, oh wait, if it's not implemented correctly and the tool's not great and useful, we should probably pay them more. So when we saw historically, typically the advice was go to the front office. And I would argue these are non-quants. It's just analytics. That's all you're doing. It's an analytics job. You could have a business analytics degree. You could have simple, you're just doing averages and you're checking errors and you're trying to come up with some strategies. So you need some of that business finance side. And I'll talk about the skills here in a second. But as we started realizing with funds, that a lot of the competitive advantage and edge here was going to be the statistical, mathematical modeling and applications. And I would argue this is probably still one of the most untapped areas of the industry. Now, I see everyone now saying, I'm building models. I hired a bunch of people. I'm really excited. And your models suck and you're not making money because you don't have good quants who understand the critical problems, that understand the model assumptions, that understand all the pieces that go into this. And then even on the implementation side as well, I'm seeing now it's very, very odd. Monte Carlo simulation is kind of like data science. It's the numerical methods approach for approximating something because we don't have an exact solution for it typically. But now I'm starting to realize that's not really the case. People are doing some sort of estimation, not because there's no other option. It's just they don't know any other tools here. So Monte Carlo has been abused a lot by the finance industry. Machine learning and data science has been as well. We just throw a bunch of data in, we approximate it, we get something out. That has resulted in, I think, more shift in importance to the model development and to the implementation of these tools. But at the same time, there's still a lot of room in these markets to get more efficient to build better firms here. But the skills, let's talk about the skills and let's tie these back to that sheet real quick. When we go to the original categories that I had here. We have front office and desk quant. So again, this is front office. This is going to be a desk quant. Again, you are sitting on the front. You are doing the analytics. You are making the decisions. Again, you're not really smart in that sense. The model's really smart, but you have to be smart in the sense of reading markets, figuring out when to apply the tools, when not to apply the tools. Now, the skills here are going to be analytics. So this is not statistical modeling. This is not heavy amounts of mathematics. This is like using Excel, if this, then that, quick kind of analytical pieces here. But analytics, and more specifically finance and economics here. I'm going to put economics because that's critical. You need to understand the market's dynamics. You need to move quickly. You need to understand the tools, though. So this is where desk quants are a little bit different, a little bit more polished to them than a business analyst here. And this is why often firms historically didn't hire finance majors, business analysts. They were looking for someone who understand the tools when the tools are failing, not just that, the error in the model is larger, right? That could be that you aren't implementing it properly. You're not using it in the proper setting. So you need to understand the models. But that's going to be the desk quant, the front office quant, as we talked about. I'm going to say they're not really quants, right? They're analysts, they're analytics. The finance community as a whole has been catching up slowly with adding more kind of analytics and more understanding of what is a statistical p-value or a test. Again, they're doing some testing, but it's not going to be heavy amounts here. And then next, you're going to have model validation quants and research quants here, which is kind of an odd thing here. I'm going to tie in here, though, that you have model validation. And model validation is really a kickoff from all the regulatory scrutiny of this. This is a quant that goes into someone building a model, reviews their model, challenges the model, makes different decisions with it, and does all these tests behind the scenes to prove that there's not a better way, or not at least a better way they can find. Now, again, you still have that risk, but you want to separate your developers and your validators because you don't want them saying, they're a really smart guy. That model probably is going to work. You want that testing and that combativeness that goes back and forth between quants and validators. But both of these, the skills for these are going to be statistics and mathematics applied to finance using programming, more specifically like scripting. So the key skills here is understanding the business problem well enough. You're not going to be like the front office. You're not going to understand all those nitty-gritty details and seeing the movements and the balances. You're in this very slow environment where you have a set of data. The data has to be constant. You have to get a grip of your bearings. You're going to build a solid model given what the front office has requested, and you're going to use math and stats. Really, statistics is the driver of all models. I would argue statistics is just a type of mathematics. But you're going to have those two pieces here. I would argue these are the real quants. This is like historically when you go back to financial engineering, it was those that was using math and statistics to come up with prices and to engineer products here. They were not coming in and analytically driving and saying, well, what if this and what if that? They had to find the true value of an asset in itself. They took large positions in these. You look at banks now with mortgages, for example, and auto loans and credit card. You start to have longer time periods of credit cards are a little bit short term, but when you look at like auto and mortgage, you're selling some sort of product with not a 3 to 6 month window like a derivative. You're selling a 5, 10, 30-year product here. And when you have that, the amount of risk that mounts as you accumulate these over time is huge. And then this gets into how banks offload these and sell these into the buy side. So you have to get securitized and then sold off. Whole other topic. But I would argue this is the traditional quant. The skill sets that we typically talk about when we say quants is the term math comes up a lot. That's because those building models need to understand some finance, but they really need that deep stats and mathematics portion here. Now for programming, I said they're really just scripting because we're just scripting. We're trying to find a mathematical solution. So if you looked at my other videos I've posted in the links below, the one on quant research, you'll see that we're just looking for a mathematical solution to some sort of problem that requires a bunch of different stipulations based on the business here. So again, when we go back to that list, Again, validation, model validation, and model research quants are kind of like model development quants. It's just long term. These two are really doing the exact same job. It's just one's building and one's checking the work here. But you do the same process, variable selections and data cleaning and processing and fitting models and testing it statistically and looking at all the different angles. You both do the exact same thing. One's building, one's checking. That's kind of what I would view as a real quant. That's really the only quant here. Now let's go into quant dev quickly, and then I will nail stats arb quants and capital quants. So again, I said quant dev is here. Quant dev is going to be heavily focused in CS and math. Why I say that is they don't really need to do the statistical modeling. That's already been done. The math equations are already found. They know that's the correct solution, given the inputs and the problem and everything else. A quant dev's job is to figure out how do we implement this faster and better. So they might see the quants were, trying to hurry and get to a math equation quickly. They maybe missed a more mathematically optimal solution there, a faster way to calculate it, a more simple way to do it. You can, in mathematics, you write things out and you cancel things and it simplifies down. You can do things like that sometimes and get a simpler equation mathematically. Software-wise, again, is huge. Computer science, understanding both the hardware engineering side and the software engineering side. The hardware itself, what CPUs you're using, can you get GPUs to speed up the process? Can you run in parallel? Again, what is your access to hardware? Should you buy different hardware? Also, the software piece of writing the code, optimizing the code, controlling for memory. I think a lot of people fail to realize this. We are not like generic software engineers trying to get a product to market. We are trying to build something very simplified to the bare bones. We're boiling this down here. And to do that, you need a computer scientist that really understands math and really has a deep understanding of computer systems and how to put all this together here. So again, the skills for this are going to be computer science and math. Again, they will have more math skills though than a typical computer scientist or a DevOps kind of person. And then we start to muddy the water here with stats arb. So we have what I called stats arbitrage. We also have capital quants. I'm going to say these are job specific. This would be like if I started making up other categories like, well, you're a credit quant, right? So instead of capital, you could say, well, I'm a credit quant. Or, I'm an FX quant, which people start to do this. To me, it doesn't really matter. Do you know the math stats? Can you build really good models? Now, again, if you start to look at quant dev as well, having some expertise there, you would probably then you could differentiate those and say, oh, it's a capital quant dev. And then you could get into the front office or the desk quant, go, oh, I'm a capital front office quant, or I'm a capital desk quant, or I'm an FX quant. There's all these other things. These things are kind of jobs in themselves. I'm going to cross them out. They're just job specific here. And I'm going to put a little caveat here because I have to do this. I always have to do this. High frequency trading is very different business model wise. They do not own a lot of assets. They typically do not, especially when you look at banks, the sell side. They're going to own a smaller pool of assets. They're going to churn these very quickly to scalp off the bid-ask spreads there, which is what they're doing. They're making a market. They're making liquidity for these exchanges and the traders and everything else. HFT tends not to have these really big teams here, where when you get to an investment firm, you can move and have quants developing models, and then you can have another department of quant devs, and you can have your front office, and you can have accountants and finance and HR, and you have this whole staff of people, and it moves as one giant behemoth here, whether it's asset management or the banks. The banks are huge. Hundreds of quants, some of these firms. They're all moving in one direction very slowly, so they all have very specialized jobs here. Now, historically, that's not how it was. Everyone operated more like HFT. There were small firms coming in to pick off the big guys, use a new technique, use a little bit of edge here, use a little bit of math and stats, and put it together. I mean, Jim Simmons is a perfect example of that. But HFT today, I don't think it makes sense to have a large fund or a large firm in many cases. Now, Citadel is probably an exception to this. But again, HFT typically operates a little bit faster at smaller firms, so you might start blending these roles together, which is why this gets really confusing skills-wise, because you go, well, they want me to build models, which are going to be simplified models. They're not going to be these massive models that take 3, 6, 9, 12 months to develop. It's going to be you have like a week or two to come up with an idea, a strategy, put the model together for these HFTs, execute on it, and then have something come out at the end here. You don't have as much skin in the game. You're not sitting in a position for 6, 12, 24, 48 months like a bank when you're actually engineering products, or an asset management fund if you have a long-term strategy, or you're in it short. So you're trying to find super simple dynamics. The markets are moving fast. You don't have time. It makes no sense to do long-term model development. So your model development is going to be far simpler. The tools you're going to use are simpler. The theory is going to be simpler. Now, again, you could get more complicated frameworks and build them out long-term. I'm not saying that it's not a thing. But typically in HFT, you have people doing like the model development, the implementation together. And a lot of times you even put the trading in there. And then HFT often calls these like quant trader. Again, I would say you need to have a lot more front office skills to be a quant trader. It's really more like a trader with some programming and a little bit of math and stats here. But you have to be a generalist. Now, it's kind of up to you what you want to do. I think the job market's too volatile. I've talked about in past videos, maybe I'll link those below as well. Quants think slow, traders think fast. There are very few people that can do both, and I would argue if you can do both, you probably are nowhere near the best in either one of them, or you're really good at one and mediocre at the other. It's really hard to be really good at two different things because the thought process, the skill sets are very different here. So I hope you guys found this video helpful on the skills to focus on, maybe the degrees to look at. People ask me, Dimitri, should I get a math degree, a stats degree? I think statistics is a lot better for the model development side. I really do. But I think having some of the core math skills like measure theory and like analysis class, so some of those kind of overcross proofs course, for example, they're the really boring math classes to many people, but they're the hard logical skills that you will need across the spectrum here in quantitative finance. From quant dev, again, I would do a CS or math degree typically. Financial engineering degrees for masters, not for undergrads, because in undergrad, you should specialize in one of the areas, math, stats, computer science. And then you should, you can get a generalized degree like in my financial engineering degree. You can kind of blend all these skills together. And again, if you're the front office here, go to a really fancy big name school like Princeton or Yale or Harvard, or I don't know, a big name business school out there like Booth or Stern or Wharton. I don't know. Pick one of these ridiculous business schools. Go get a finance degree, maybe get a stats degree, but you need that networking ability often to get into the front side of this. Again, not really my forte, not much I'm interested in there, but you can kind of look online as well and look at what people are doing and kind of their skill sets. So anyways, thanks for listening. Thanks for watching. And as always, until next time.